Price, income and cross elasticities of demand. Price elasticity of demand shows how demand changes with price. PED is a measure of how the quantity demanded of a good responds to a change in its price. It's calculated with the formula percentage change in the quantity demanded over the percentage change in price. You can think of PED as the way that consumers react to a price change. We should note that the price elasticity of demand is usually negative because demand falls as price increases for most goods. So if you look at the formula on the screen, imagine that the price increase of the good was 40%, and imagine that the quantity demanded fell by 33%. Well, obviously you would have minus 33 on the top of the formula because the quantity demanded fell, and 40% at the bottom of the formula. So the answer would come out roughly about minus 0.8. But the price of elasticity demand, in spite being negative, we ignore the sign. So we usually scrub out the negative. So I'll just show you an example on the screen now for that point. So if there was a fall in the quantity demanded of minus 33.3% and the price increased by 40%, our answer would be minus 0.83. The key thing here is that the negative is showing the inverse relationship between quantity demanded and price as per the demand curve. In other words, price goes down, quantity demanded goes up. There's a negative relationship, and vice versa in the other direction when there's a price increase. So therefore we simply scrub out the minus and we ignore it as far as the PED calculation goes. Also, please note there is no percentage sign. So this here is definitely not a percentage sign. It's a coefficient. So we just leave it 0.83. PED can be elastic, or unit elastic, sometimes known as unitary. So let's repeat: elastic, inelastic, or unitary. So we can see here with the elastic diagram. Okay, now you can see with the elastic diagram let's change that so it's a bit clearer. You can see with the elastic diagram that the demand curve is fairly shallow, okay, fairly flat. In comparison, when it's perfectly elastic, the demand curve is perfectly flat, okay. So what we can see, if we take the first diagram on the screen and we focus on that one, diagram 1, relatively elastic, PED will be more than 1. If the value of PED, again, ignoring any minus sign, is greater than 1, demand for the good is elastic. This means the percentage change in price will cause a larger percentage change in quantity demanded. The higher the value of PED, the more elastic is the demand for the good. In the diagram on the screen, price falls from 50 to 40 pounds. And an extra 45 units are demanded, i.e. the difference between 30 and 75, which gives an elastic PED of minus 7.5. So if you were to plug all those numbers in and do some percentage changes, the figure would come up as minus 7.5. So to work out that percentage change, what you would do is you would do 45 over 30 times 100 divided by minus 10 over 50 times 100. And that would give us minus 7.5. So we know that in simple terms, this would come out as 7.5. But remember, we ignore the minus. So it's 7.5, meaning that for every 1% change in price, there will be a 75% change in the quantity demanded. So in other words, for every 1% fall in price, demand will increase by 7.5%. For every 1% increase in price, the quantity demanded will fall by 7.5%. Okay, so again, we ignore, remember, the percentage signs. Perfectly elastic demand has a PED of infinity. So the diagram on the right of that one, number 2, is infinity, and any increase in price means that the demand will fall to 0. Consumers are willing to buy all they can at price P, but none above price P. Inelastic. So let's look at that now. Relatively inelastic demand. That's when the number is less than 1. Okay, so when it's less than 1, we call that inelastic. If it was 0, it would be perfectly inelastic. The value of PED for goods with inelastic demand, again ignoring the minus signs, is between 0 and 1. This means a percentage change in price will cause a small percentage change in the quantity demanded. The smaller the value of PED, the more inelastic demand is for the good. In diagram 3, price falls from £50 to £40, a 20% decrease, and only an extra 4 units, which is 8%, increase in quantity demanded. This gives an inelastic PED of minus 0.4. Again, we ignore the minus and we're left with 0.4. So for every 1% fall in price, there will be just a 0.4% increase in quantity demanded. Perfectly inelastic demand, on the other hand, is a PED of 0, and any change in price will have no effect on the quantity demanded. So if you look here, price goes up to P2, but look, the quantity demanded has not changed at all. Unitary equals 1. A good has unit inelasticity or is unitary if the size of the percentage change in price is equal to the size of the percentage change in quantity demanded. So on my diagram here, you can see that a 20% decrease in price is matched by a 20% increase in the quantity demanded. If you divide percentage change in quantity demand of 20 by a percentage change in price of 20, you will end up with the answer 1. Okay, so 1 equals unitary. Income elasticity of demand shows how demand changes with income. The income elasticity of demand measures how much the demand for a good changes with a change in real income. It can be calculated with a percentage change in the quantity demanded of a good over the percentage change in income. If real income increased by 10%, and because of this the demand for cameras increased by 15%, you would do 15% over 10%, and the answer you would end up with is 1.5. Okay, so let's move on a bit. You can see that there are a couple things to consider. Now, we have the income elastic first and foremost. So the income elastic is this one here on the screen. And an increase in income of £5,000, i.e. the difference between these two here. So an increase in income of £5,000 leads to an increase in the demand for the good of 6 units. This gives an elastic or relatively elastic YED of 5.4%. So you can see the numbers below that were plugged in. So for every 1% increase in income, the quantity demanded increases by 5.4%. On the diagram to the right, you can see an increase in income of £5,000, again, here, look, leads to an increase in the quantity demanded for the good of just one unit. This would give a YED of 0.9%. So there's a couple of things that I need to talk to you about regarding this. So I'll just scribble these here at the bottom of the page. If the number is plus 0.9 or minus 0.9 or plus 5 or minus 5, what we have to do is always separate the sign from the size all the way along. The sign, if it's a minus, tells us that this is an inferior good. And that means if income goes up, the quantity demanded for the product will fall. If income were to increase, the quantity demanded falls. If the income was to go down, the quantity demanded of that product would increase. So a good way to think is like Aldi or Lidl supermarkets or own brand products in supermarkets. So that's inferior as well. In contrast, we have the plus sign. Now the plus sign is telling us that it is a normal good. All normal means is that if income increases, the quantity demanded increases. However, if income were to fall, the quantity demanded for the product would fall. Okay, so if I looked at plus 0.9, we then consider the size. So the greater the number, the stronger the relationship between the income and the quantity demanded of the product. So for instance, if my income goes up, I am much more likely to go and buy the product if there is a high number such as 5 or 7 or 8, whatever it might be. So in other words, if the number is greater than 1, we say the product is income elastic. In other words, much more likely as income goes up, people are going to demand that product. Conversely, if income was to go down, much more likely they are to give that product up. So that was 5. And that one was 5. Now, some students would go, well, minus 5 should be simply inferior and income inelastic. That's to confuse the issue. Look, if you take that out, 5 is more than 1. So it's income elastic with an E. Finally, you've got income inelastic, and you've got income inelastic. So I would now just freeze the screen and take some time to digest that. You're separating the sign from the size. Also, you need to know about the cross elasticity of demand. The cross elasticity of demand, XED, is a measure of how the quantity demanded of one good responds to a change in the price of another good. It can be calculated with the formula above. Percentage change in quantity demanded of good A over the percentage change in price of good B. So let's just add that so it's clear. Of good B of good A. So, if two goods are substitutes, the XED will be positive. So let's just talk about that now. So if quantity demand goes up and that price of B goes up, that will be a substitute. So imagine toy cars and teddy bears are substitute. If the price of toy cars rose, so toy cars being good B in this case, by 40%, and the quantity demanded of teddy bears would then increase by 20% because people would stop buying toy cars and instead buy teddy bears. So I'll just note that down. So you would see that 20% divided by 40% would be 0.5, and it's a positive because these are both going in the same direction. Plus 0.5. So what we would do, as we've done with the income, is we would separate the plus, change colour to make it clearer for you. We'd separate the plus from the 0.5. Because we're talking now about cross-elastic, we have to use some different terminology. So the plus sign illustrates it's a substitute. The 0.5, because it's less than 1, would be cross-inelastic because it's less than 1. The plus is a substitute this time. So with the tennis balls and tennis rackets, we're going to see that these are complements. So you can see that the arrow for tennis rackets is increasing. That's telling us the price of tennis rackets are increasing. So unsurprisingly, people buy less tennis rackets. Well, obviously, if you buy less tennis rackets, you're going to demand less tennis balls. This explains why the arrow for tennis balls is pointing down. So there's a 30% fall in the quantity demanded of tennis balls. This would give us an answer of minus 0.6. So again, what we're going to do here, we separate sign from size. Minus is telling us it is a complement good, and the 0.6 is telling us it is cross-inelastic because it is less than 1. Thank you for listening.